Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals, right? And here we have to evaluate this integral that is from -1 to 0, and here we have greatest integer of 1 plus x times signum of x divided by square root of fractional part of x plus 1, right? So here we see that the integrand, it involves the greatest integer function and the fractional part function and the signum function, right? So let us start and let us see the definition of signum function and fractional part function. So before moving further, let us first see the definition of signum function, right? So signum of x is defined like this. That is, signum of x will take the value +1 whenever x is greater than 0. Signum of x takes the value 0 whenever x is 0. And signum of x is -1 whenever x is less than 0, right? So this is the definition of signum x which will be utilized while solving this integral, right? And the fractional part of x is defined like this. That is, it is the difference of x and the greatest integer of x, right? Okay, so now let us first take this integral as I, right? So now here we see that the limits of integration are from -1 to 0, right? So x, it varies from -1 to 0, right? So when x varies from -1 to 0, it implies that x lies between -1 and 0. Then the fractional part of x will take the value x plus 1, right? Why? Because see, when x lies between -1 and 0, then the greatest integer of x will take the value -1, right? So here we have x minus and minus of 1, so we have x plus 1, right? So here the fractional part of x can now be replaced by x plus 1. So the fractional part of x plus 1, it becomes x plus 1, that is equal to x plus 2, right? Okay, and here in the numerator we have the greatest integer of 1 plus x times signum of x, and here x goes from -1 to 0, right? So it means all the values of x are less than 0. So in our integral, signum of x is equal to negative of 1, right? Because x goes from -1 to 0, and all the values of x which lies in the interval -1 and 0, all are less than 0, right? So now this integral I takes the form -1 to 0, and we have greatest integer of 1 plus x times -1, and here we have square root of x plus 2, right? Because the fractional part of x plus 1 is x plus 2. So now here we have dx, right? So now we can write the integral from -1 to 0, and here we have greatest integer of 1 minus x divided by square root of x plus 2 and dx, right? So now in this integral we have in the numerator greatest integer of 1 minus x, right? So now let us try to write the value of greatest integer of 1 minus x when x goes from -1 to 0, right? So here x lies between -1 and 0. So what we will do to write the value of greatest integer of 1 minus x, we'll multiply this inequality by -1, right? So here we have 1, and the direction of the inequality get reversed. So here we have 0. Now we can write this inequality as 0 less than, here we have minus x, and here we have 1, right? Now let us add 1 to this inequality. So we have 1 plus 0 here. Here we have 1 minus x. Here we have 1 plus 1, right? So here we have 1. Here we have 1 minus x, and here we have 2, right? So now we see that 1 minus x lies between 1 and 2. So the greatest integer of 1 minus x must be equal to 1, right? So here we can write 1. So now this integral I, it takes the form minus 1 to 0, and here we have 1 divided by a square root of x plus 2 dx, right? So now we have a very simple integral, and this integral can also be solved by using the method of substitution, right? So here what we will do, we'll take t square is equal to x plus 2, right? So differentiating both sides, so we have 2t dt is equal to dx, right? Now let us change the limits. So when x is minus 1 here, then we have t square is equal to minus 1 plus 2, that is 1, so t is 1. And when x is 0, then the value of t square is 0 plus 2, that is 2, so t is equal to square root of 2. So when x varies from minus 1 to 0, then t goes from 1 to square root of 2. So now this integral I can be written as from 1 to square root of 2, and for dx we can write 2t 2t dt, right? And here we have simply t, because here t is equal to square root of x plus 2, right? So now this t and this t get cancelled, so we are left with 2 times integral from 1 to square root of 2, and here we have dt, right? So now the integral dt is simply t, and the limits are 1 to square root of 2, so we have 2 times square root of 2 minus 1, so this is 2 root 2 minus 2, right? So viewers, the value of this integral is the 2 root 2 minus 2.